In this lesson, I'm going to talk about bisectors, I'm going to talk about segment bisectors, and I'm going to talk about angle bisectors, and some of the properties dealing with both of them. Now, in this first one, again, I'm going back to my picture part. So if the green stuff is true, and what I see in the green is I see a segment here that has been bisected, because I know these two pieces are congruent, therefore this is bisecting, and I notice that it's perpendicular. So when you look at the word part of the theorem, if a point on the perpendicular bisector if a point is on the perpendicular bisector of a segment, well, then what do we know? I'm going to go to Sketchpad to help us out with that. So what I've constructed here is, here's my segment, this is a perpendicular bisector. I made it that way. You don't necessarily see it, but that's how I've constructed it. If I move it, doesn't matter, it's going to stay that way. Now, here's point A, so that's my point that's on my perpendicular bisector. And what I want you to notice is, I'm going to look at the distances. Now, my distances are from that point back to the endpoints of my original segment. This distance is 5.94, this one's 5.94. So right now they're equal. If I move point A, notice they stay equal. It doesn't matter where I go, they're going to stay equal. Even if I change my segment, doesn't matter where that point is, as long as it stays on the perpendicular bisector, that distance is going to be equal back to both. Bring me back here. So if I know this, then the red is going to be true, which is just saying what it does down here in the words, that point is equidistant to the two endpoints, meaning it's the same distance from here to here and from here back down to here. So if it's on the perpendicular, if a point's on the perpendicular bisector of a segment, it's going to be equidistant to the two endpoints. Now my next one, I'm going to get rid of this for now. Save that. My next one looks like this. So now I have, I guess I didn't put the words on this one, I apologize, I think they show up on the next slide. This one says that if a point, so that's my point up there, if a point is equidistant from the two endpoints of a segment, well then what do we know? And here I'm going to help you. So here I have it, my point A, it's equidistant to point B and to point C. You look at it, doesn't matter how I do this, I've constructed this so that it stays equidistant to the two. What I'm going to do is I'm going to trace that point. If I can remember where the trace is at. Trace that point, there we go. Now, as I trace this point, you start to see something appear. Well, it looks like a line. But what's special about that line is, notice, it looks like it's bisecting the segment and it looks perpendicular. Well, if I click that, this shows it that yes, in fact, that all these points are creating a line that's the perpendicular bisector of the segment. What we just looked at was the converse of the theorem that we just had earlier. Click to my next one. Yep, there's all the words. So if a point is equidistant to the two endpoints of a segment, then it's going to fall on the perpendicular bisector of that original segment. Now let's go angles. Again, I guess I left the words off. They'll be on the next slide. But what this one is talking about, it says if a point's on an angle bisector, then we're going to learn something. Notice this ray in the kind of the middle of the angle is bisecting the angle because I have the two congruent little angles. So if a point's on the angle bisector, what else are we going to know? And that's what I have here. I have an angle and I can change my angle, but that kind of lime green color is always going to be the angle bisector. Here's my point that's on it. What I'm going to look at is how far that point is back to the sides. And what you're noticing is that distance back to the two sides is always going to be equal. Close that down, come here. Now I look at my next slide. There we go. If a point's on an angle bisector, which this point right here is showing, then it's going to be equidistant to the two sides. So I'm showing the distance. This shows distance, this shows distance back to the two sides, and those two distances are going to be equal. On my last one, now on this one I have an angle, and I'm going to talk about a point. Now on this one it says if a point is equidistant to the two sides of an angle, then we're going to learn something. Bring back to Sketchpad. Now notice here my point A is equidistant to side BC and equidistant to side BD. Well, where is that point? Again, I can trace this, and you're going to see a ray start to form here. Well, that array appears to be bisecting the angle, and yes, in fact, it is. No matter where, as long as that point stays equidistant from the two sides, it's going to stay on the angle bisector. If I come back here and on my next slide, just like we said, if a point's equidistant from the two sides of an angle, then it's going to fall on the angle bisector. So those are the 4 theorems from today. There are kind of 2 theorems and then converses of the 2. They go both ways. And I'm going to use one of those theorems in this problem. Now when you look at this problem at the beginning, it looks very complex, very confusing. So what I've done is I've used color to try to help us identify different pieces in this triangle, because there's definitely a lot going on. But it tells us that line L, line M, and line N are perpendicular bisectors of the triangle PQR, which means they're perpendicular bisectors of the sides. So when I look at line L, just to highlight it, well, that's the perpendicular bisector of segment PR. If you go to, say, line M, now that's the perpendicular bisector of side PQ. And I can show you the other one as well. I will not. What I need to do is I need to figure out my values of x, y, and z. Well, I notice that the x, y, and z are part of lengths of different pieces that are in this triangle. So I look at this, I'm going to look at x first. It tells me that from Q to this point T is 2x long. But I also look at this and I go, well, from R to T is 8 units long. Now being point T is on line N, let me highlight this. What color? I'll use black. Here's line N, which remember, line N is a perpendicular bisector of segment QR. So if a point is on the perpendicular bisector of a segment, it's equidistant to the two sides. I misspoke there. The point T is not going to be equidistant to the two sides of the segment, it's equidistant to the two endpoints. So my distance from T to Q and my distance from T to R are going to be equal. Well, that tells me that 2x and 8 are going to have to be equal. So I'm just going to write that. 2x and 8, we said, are going to have to be equal. Now I have an equation that I think is going to be pretty straightforward to solve. I'm going to divide both sides of my equation by 2, and I just found out that x equals 4. One variable down, 2 to go. I'm going to get rid of that so it doesn't create more confusion. I'm going to get rid of that. Now I'm going to go to point y. Well, point y, or excuse me, not point y, variable y, that's part of the green length. It tells us that from point P to T is 3y minus 1. Well, we already know that from point T to R is 8. And again, T is on now that perpendicular bisector of segment PR. Therefore, the distance from T to P and the distance from T to R are going to have to be equal. Now in this one, I can then use those two distances. My 3y minus 1, my 8, those are going to have to be equal. Solve an equation, and I'll have it. Again, this one's going to take, whoops, I didn't want to use that color. This one's going to take a little bit longer, not a whole lot though. Add my 1 to both sides. So now 3y is going to equal 9. Divide both sides by 3, and I just found out that y is going to have to equal 3. 2 variables down, 1 to go. Now my last one is just going to be the z. Well, z is just part of one of the sides, segment PR. Well, again, I'm going to come back here to this segment. It's the perpendicular bisector of segment PR. Well, that's telling me then that my z plus 4 is going to have to be just as long as the 7 So those two lengths are going to be equal. Go through, solve my equation. I made the equations pretty easy, hopefully, to solve. So I just wanted to focus on that concept of if a point is on the perpendicular bisector of a segment, then it's equidistant to the two endpoints. So right there I figured out what x, y, and z are based off of that theorem that said if a point is on a perpendicular bisector of a segment, then it's equidistant to the two sides. And that's going to be my one example and my only example for this. We could have looked at examples dealing with the last couple of theorems as well. I chose not to in this one. If you run into those, use the theorems, set up your equations, solve, and you'll have it. But if you have questions, feel free, let me know.